Okay, so this is try 2 at beginning the machining on this flange. I'm gonna go a different way. I'm not gonna contour first. First thing I'm gonna do is do some facing. So before we do some facing, probably should get a facing cutter. So I'm gonna filter to get face mills. You can always face mill with you can face mill with an end mill, but it takes a long time and it doesn't give the greatest finish always. Face mills give really nice finishes. So just select face mill and I turn off the tool diameter. There won't be as many as end mill sizes. So 2.5 is a good general face mill. 2.5-inch face mill is a good general face mill. It's not too big, but of course you pick the one you've got for your system. And before I forget, double click, and so now tool number 4 is a face mill. Okay, so let's do some facing. And I guess before we do the facing, let's talk about why are we doing the facing. So let me go to stock setup, and I'm going to display as a transparent solid our workpiece. So if we zoom in here, we've got a certain amount of height above the part here. We've got to deck this whole thing off here. This all has to come off, and it doesn't matter if we nibble at it first on the outside and go all the way up, and then this side and go all the way up, and then here and go all the way up, and here and go all the way up. We've got to get rid of all of that. So it's a good idea just to do some real simple bulk material removal, and this is just the simplest operation you can do. Facing is super simple, and when nothing is sticking up above the facing, it makes it just a no-brainer. You don't have to avoid things. It's real easy. So let's go ahead and do that. So we can turn off the stock display here. Okay, so to face, we need to turn on. We're gonna have to. Oops, sorry, wrong one. We're gonna have to turn on the stock. So I'll turn on the picture of the stock, and you'll see shortly why I have to turn on the stock, because we're going to have to select the whole stock. So tool paths. So let's do face. Hit OK. C-plane wireframe. And I'm going to select that. So you can see green line goes all the way, or chains all the way around to the red line. And when we get into contouring, we'll get into more detail in the chaining. If I couple tips about chaining, I can deselect using this circle with the slash. I don't use a whole lot of things in here. I'll tell you the one thing I do use is this is the default selected chain. You want to understand the difference between C-plane and 3D and wireframe and solid. So let's go through those. Wireframe, let me deselect everything. So wireframe, when I'm selecting things, you can see it's highlighting on lines. It's not highlighting on surfaces, it's highlighting on lines. If I go to 3D, it's highlighting surfaces, which is shown with the red line that goes all the way around the surface. So it's just a fundamental different way of selecting things. So but we're going to start out with wireframes and selecting lines, because it makes a lot of sense for things like contouring and things like that. It's a good place to start. Next thing is 3D and C-plane. C-plane, it will tell you that you're operating in the XY plane of your construction coordinate system, and it's real important to understand the advantages of C-plane. Typically, a lot of, not all, but many machining operations happen in the plane of XY on the tooling plane or the construction plane, and in addition, the cutter comes perpendicularly down from the Z-axis of the C-plane. And what that does for you is it means there's a lot of cuts that you can chain that solely exist in the C-plane. They don't exist. There's no way that I'm going to chain for this facing operation something that starts down this line, goes down here, over here, back up, over here, and back here. It just doesn't make sense to do with a single facing operation. You need some 5-axis mill to deck it here and back down. So if I go to 3D and select this line, you can see it starts here with this green arrow. It's a little tough to see. It goes to this red arrow, and then it gets stuck because it doesn't know if it's going to go down the Z or across over here in the X direction. So if I deselect that and I zoom in and out just to clear the little drawing remnants. If I switch to C-plane, that same selection now starts with the green arrow, and it says, where am I going here? Well, there's only one choice because I'm not allowed to leave the C-plane, which would be down the Z here. So I'm going this way, make a left. Oh, what are my choices in the C-plane? Only choice is to go this way, and it follows it around until it hits the starting spot. And now it's made a nice closed chain, which is what we're going to want to choose. So this is the chain we want to do, but I want to make one more point. Here, let's see. So this allows me to change to single line, and I'll show some details about choosing lines. So I'm gonna focus on choosing this line down here just to show some details about choosing lines. So I'll delete my selections. If I choose this line down here, it matters where I click on it, because when I click here, I'm closest to this vertex as opposed to the other vertex, which is over here. And if it's an arc, it's the same thing. It's only got 2 vertices, one on either end. The arc's continuous radius otherwise. The reason it matters is in machining, climb milling and conventional milling matter, and it gives the CAM system information about which direction things are going, which side to cut on, by noting the direction of your chain. So the reason it chose this vertex is because I was on the left side of the line I'm selecting, and it's not really about left or right. It's where I guess it's the closest vertex. So if I deselect, let's do it again, and I'd say this is about the center. So just to be safe, I'm going to go over here, and you can see, sure enough, it grabs the left side. If I deselect, here's about the center, go over here, grabs the right side. So super simple. It shouldn't be hard to do unless you've got a big mess of lines everywhere like this. Then sometimes it's hard to see, but physically to grab it, let's say that this thing zoomed way out. Now it's hard to see what I'm grabbing. Well, the answer is real simple. Just zoom in enough where you can see it. So if I say I want to grab this, and I want to grab this vertex going in the right direction, I can grab it here, I can grab it here, I can grab it here. Around here's the middle, I can't tell. I can't tell exactly what side I want. So I just grab it where it's easy. It doesn't matter if I grab it here, grab it here, or grab it here. But the key thing is that even if I don't have a particular direction that I have to go, I still think about the direction I want to grab. You should always be grabbing the line where you intend to. And if you intend to grab it in the wrong spot, you made a mistake, that's fine. But just get in the habit of grabbing it in a certain location. Okay, so let's back out here. Let's deselect everything. And I'm going to shade things in, because what I want to do is just grab the chain around the top, because that's what we're going to face. We're not going to face at this height, but we're going to face this area here, and we can control the height later. So there, oops, let me go back and set it to chain. So I'm on single line, I want to set it to chain. Okay, so now green starts here, goes all the way around. Let me do a little slower. Goes all the way around here on these 4 lines, and successfully the red and the green arrow meet at their starting point, not at the tips, and that's a sign that's a successful chain. Okay? So now we've got a bunch of things we've got to do. Tool path's already selected for us. It's facing. It's kind of hard to see. I can select it and make it bluer, but it was a light gray. Next tool, I'm going to pick the face mill. Holder, always use holders. So cat 40 ER 32. That doesn't look right. Oh, that's because it's got the face mill in the front. Cut parameters. you can do one way. There's a bunch of them in here, but usually for me it comes down to one way, which is I cut one direction, it goes up and then down and then cuts in that same direction. That leaves a more uniform surface finish. I don't really care usually with super precision what the surface finish is going to be like. So the zigzag where it cuts in both directions is faster. You spend more time cutting, less time moving. And then the other one I do is high-speed loops, gives it a nice round corner and doesn't shake the machine as much. That's a super subtle thing. You probably never see any evidence of it in the cuts, but if nothing else, it looks cool. And then depth cuts. You definitely want to be aware of depth cuts in a face mill, because if something's if you got a face mill that's 4 inches wide, it's really easy to bury it in a piece of work, and that piece of work is just going to stall things out. So, oops. So what I'm going to do is a rough step, so it's going to keep going down 1/8 of an inch at a time until it is 1/10 thou away, which I specified. I want 1/10 thou finishing cut. It's going to use the same cutter. It just takes a light cut, kind of like imagine you're in the lathe and you're hogging stuff off. Sometimes the finish doesn't always look so great, and then you go to a nice light skim cut, and it can look pretty. Especially in aluminum, that sort of stuff works. But you don't want to do a 1/2 thou. You want to actually take a cut. So I use 1/10 thou. You can, of course, you can omit this. Probably your face mill will work great without it. But I tend to take a 1/10 thou cut on things. Linking parameters. This is super important. You have to specify the depth. So I'm going to wireframe this. Now, where's the depth we want to cut? The depth is this boss up here, so I can select this circle or that circle or one of these endpoints here. So real simple, just select that. That's the depth. Now next is the top of stock. So this is going to be the highest piece of stock that the tool could hit by zooming around when it's not cutting. It doesn't mean the highest piece of stock in the whole machine. It means this is the height that it's going to cruise around when it's moving from part to part, or moving from one piece of the part to another piece of the part while it's not cutting. In simulation, you can go ahead and fine-tune this and understand if it's going to hit something, but for our purposes here, top of the stock is the literal top of the stock, which is 0. And later on, when the next operation, the top of the stock will be this negative 0.358 number, and there's no reason to consider the top of the stock something you have already cut away. But since this is the first operation, nothing's been cut away. So we don't actually move around here. This is to tell the tell the CAM program this is where you start cutting. Next one up is a feed plane, and this says where do you drive around when you're trying to move from one part to the other. So when you drive around at the exact top of stock, no, you're not going to do that, because you're going to rub. The cutter will rub and leave a mark on the top of the stock. So I clear it by 100 thou is usually a good one. Top of the stock is an absolute coordinate. You can do an incremental if it makes sense. It doesn't really make sense to me a lot. Feed plane being incremental over the top of stock can be convenient, because you very often will just want to cruise around 100 thou over the top of stock, and the next time next cut you do, these settings will be left in there, and so you don't have to adjust this very often. And then retract is at the beginning and the end of things. How high does it go up to just sort of clear away? So as long incremental over the, it's tough. You got to really think about what you're doing here. An absolute that's well above your top of stock is probably a good one. You could also do incremental and automate stuff a little more. You could even turn it off and just use the feed plane. But a 1/4 inch over your top of stock, your original top of stock, is not a bad place. You don't spend a lot of time at retract, so this isn't one of those places you go to save lots of time in machining. So this is a decent one to start out with, and we can, in the future video, we can look at the paths and play with these a bit to understand what's going on. Next thing is planes. Let's make usually you don't have to adjust this. If you start out with your CNT plane on your correct milling coordinate system, you shouldn't have to adjust this. This should just come out working right. So your WCS is top, your T and C planes are mill top for this example. That's fine. I don't adjust it. If this is not right because you've been messing with things, this is a good place to fix it before you start calculating your tool path. You always can go in and fix it later, but want to get it right off the bat. So with coolant, real simple. Turn on your flood coolant. I'm assuming you're going to use it. These are just these are what, M codes. Yeah, M codes I think that turn it on. Keeps you from having to sit there and punch buttons while you're trying to figure out if this thing's crashing. Say OK, and now you can see a whole bunch of tool paths. So if I zoom out, there's my tool path. That looks normal. It's going to go in here. It's going to make some cuts. It looks like it's going to be an 1/8 inch deep, and then a third pass tells me that let's zoom in. So here's an 1/8 inch deep cut, another 1/8 inch or close to it deep cut, and then there's the 10th thou finish cut. So that makes sense. And you can see if we zoom out and we look at it from the top, they're all right on top of each other. That's normal. And it starts off the piece, goes past off the piece, and it does all the turning around off the piece. I guess somehow I didn't catch it and talk about it. Let's go back into parameters just to look at one thing and understand it. Cut parameters, there's lots of numbers all over the place, and all these numbers, they make sense to somebody. Somebody's using every one of these numbers. You may not be using a bunch of them, but I'd say in facing, the two that you'll really use are the across overlap and the along overlap. So in here, you're going along the part. The along overlap is how far out do you go here. So if you made 1,000,000%, it'd go way off the screen. If you made 0%, it would turn around with the edge of the face mill cutter would just finish cutting. So this is going along the part. Across the part is going this direction, and so the across overlap is going to tell us how much of the cutter is going to hang off the part. And when I say the part, it's the thing that you chain, so it's the outside of this workpiece. It's the stock. So just to do a comparison, let me actually try to get this thing square so we can see it a little better. Okay, so along, in this case, along is up and down, across is side to side. So let's go and let's adjust this so we can see it. So I'm going to say, let's make the cross overlap really big. I want to make it dramatic. Oh, 500 is too big. Let's say 100. So that means that it's going to make more passes, and you're going to see it's going to hang out to the side. Say OK. Now it's a dirty operation. I changed the setting, but I didn't tell it to calculate it. So the way you tell it to calculate it is go up here, regenerate all dirty operations, and now see it's hanging way off the side. It's actually 100%. It's you can see there's a pass. This is a dry. Well, I guess it's not. It's just barely hitting the corner, and because we've got some overlap on the passes, it looks there's two blue lines off the side. So that makes sense. We adjusted the across moved over, so I think it was 20, I can't remember. So I'm going to put it back, and I'm going to regenerate. So okay, so this is I think where we started. We have 110 on the along, so let's just adjust along. Let's just get a reality check that we have control over this. So I'm going to set this to 20. Not that this is a good number, but just to see it change. And then you can see those loops get real short. They actually don't even go off the end of the part. But if you think about it, when the tool is centered here, the cutter has a diameter. And so that the diameter is actually hanging off 20%, just like we asked. Or actually, it might be hanging off 20% from here, and then the loops just are the high-speed loops. But the big thing here is, I think that the across and overlaps are usually pretty good unless you're trying to do something funny like going up to a square corner and not bothering it. But in just general wide open facing, these work pretty well, but I do want you to understand where these things are. The approach distance, exit distance get to be a much finer point, and some of these things I've never touched. But I'd say these are the critical ones. One you might want to consider is stock to leave on the floor. If you're using facing just to knock bulk material off, that's fine. Just put in a number here. So if we want to leave 20 thou, we do that and regenerate, and then assume that we're just knocking bulk material off, and we're going to come do that machining later with some other machining operation. But right now I just want to face to the right height and say OK, do my regenerate, and then oops, upside down, and then I want to do a simulation or do a verify, and you'll see there you go, there's your verify. And I gotta turn off my STL compare. So there you go, that's a simple facing, and I'll do another video coming up to start doing some contouring.